What's up, guys? It's your favorite math teacher here, and today we are factoring a quadratic equation. In this instance, a is greater than 1. If you haven't watched the a is equal to 1, I would watch those first before you do this one. So in this case, my a value is 2, my b is 5, and my c is 3. So generally, you figure out, well, what are the factors of C that add up to B? But that's only when A is 1. There are two different methods. So for this method, here's how this is going to work. We will call this method 1. And so what you do is it's very similar. Instead of finding the factors of C, you find the factors of A times C that have a sum of B. So it's just kind of that one extra step. So my A value is 2 and my C value is 3. 2 times 3 is 6. So what I'm trying to do is figure out, well, what factors of 6 are going to add up to my B value, which is 5. Luckily 6 is a small number, so I have 1 times 6 and 2 times 3, and that's it. 1 plus 6 is 7, and 2 plus 3 is 5. 5 is my b value, so I'm going to use 2 and 3. So I'm going to rewrite the equation now. 2x squared plus 2x plus 3x plus 3 equals 0. Same as the other part, right? The only difference was a times c. Otherwise, you break up your middle term still, and you still cut it in half. You got first half, second half. So for this first half, both numbers are 2, so they both have a 2 in common. And then x squared and x both have a x in common. 2 divided by 2 is 1, and if I have x squared and I take x away, I have 1x left over, plus 2x divided by 2x is 1. For the second half, 3x and 3 both have a 3 in common, and when you do that, 3x divided by 3 is x, and 3 divided by 3 is 1, and so just like before, you end up with the same thing on the insides of the parentheses, and so that becomes your first term, x plus 1. Then, your second term is the leftovers, which in this case is a 2x and a positive 3. So I set that equal to 0, and that is my factored quadratic equation where a is bigger than 1.